Alright, kids, I am away today, but I am here recording what I want you guys to get done for those that want to kind of follow along with the traditional class. Go ahead and plug in your headphones if you haven't done so already. But here we go. Today the agenda should go as follows, as you see on the screen. I want you guys to reserve your questions for me tomorrow, and let's go through the lessons. And today's the lesson is on percent error, which is 6.6. If you haven't gotten there already, or you kind of want to follow along, go ahead and just understand that it's going to be in Unit B 6.6-6. And this is kind of what it looks like right here. But I want to encourage you guys to hit pause at any time. Don't mind the music. It's just from Thor Ragnarok with the Avengers coming out soon. And here we go. I'm going to go ahead and click the example.
Wow, it's pretty full. I wonder how many people are on board. 36 passengers, I think.
Accuracy is the degree to which an estimate or measurement agrees with an accepted or actual value of that measurement. When you guess the amount of something, you are trying to be as accurate as possible. Accuracy is how close an estimate or measurement is to an accepted or actual value. You can describe accuracy with a measure called percent error. Percent error equals the absolute value of the measured or estimated value minus the actual value divided by the actual value. Substitute for the measured value and the actual value. So the guess 36 passengers is off by 20%.
So the key concept here that we're looking for is the fact that we want to be able to make an estimate and understand that our estimates sometimes can be wrong. Notice that the absolute value signs are there. I want to point out that technically it doesn't really matter. You can do 45 minus 36. You can flip-flop these around, and it should be the same, but the whole point is we want to make sure that the answer is a positive value. A quick reminder also that the percentage should always be multiplied by 100 in order to get that actual, what we call percent from there. Okay. The percent value or percent error just tells you how much you're off. You obviously want to keep the percentages lower, and therefore anything is more accurate. A lot of times when we do tests or different studies, you want any case study to be more accurate with that. So let's go to part one. This is part one. We have a percent error of estimated value, the nearest whole percent. So it's almost the same thing that we just did before. What we did before was technically what we did is the change over the original. It's the same idea. But in this instance, you kind of want to look at the difference between the two, which is 45 minus 40, right? And that's going to be 5. But then what you're going to do is you're going to put the actual value that's on the bottom right there. So here we have then technically 4 over 45 as being our answer. You can just go ahead and type in your calculator. I'm going to go ahead and take my calculator out of my drawer. And that ends up being 0.11 repeating. But as we said before, we're going to multiply that by 100, so it's going to be about 11.1%. Okay, you could technically put that there. Now the percent error, they say round to the nearest whole percent, so therefore it's just going to be approximately, because you want to do that little squiggle, 11%. So that would be the answer right there. Go ahead and pause the video and try to see if you can get the answer for B and C. And then you can see that the answer is going to be 16% and 26%. Pause the video if you at any time you need to kind of double check the answers, but we'll keep going from here. We're still in part one, but there's another problem for you to kind of try out. When the estimated value is 250, whereas the actual value is 200. A quick reminder, the choices are given. You want to find out the actual value is always going to be on the bottom, and then the change is going to be on the top. So feel free to calculate that, pause it, and then we'll kind of go from there. And we have B as being the answer. Lucaccioni, I guess you are right that B is quite often the answer. There's another one for the Got It Part 1, but we're going to go ahead and skip to Part 2. So far the lesson is about 5 minutes long without interruptions. But we'll take a look at what this says right here. Take a moment to read what the problem says. Anyone who guesses within 5% of the actual number of jelly beans in a jar is a winner. Suppose that there are 486 jelly beans in the jar. Who wins? I actually remember doing this a lot when my father's picnics for his companies, where you have to guess how many candies in a jar, and whoever guessed closest would get a pretty good surprise, or a prize for that matter. So we have all these particular guesses, right? But then we have the actual one. So we have to, in the end, we have to consider looking at every single person. We look at J's. I'm going to go ahead and do one of them, and then I kind of want you to try try one out yourselves. So we look at J, and we have 450, and we're basically going to subtract that from 486. Now I know that's going to get us a negative answer, but the thing is, we don't want to keep it as negative. So you can flip-flop the numbers if you want. But the answer is going to be 36. And we're going to put that over the actual number. Now, this is the actual number because that's what we care about in terms of to compare it with others. And that ends up being 0.074. And we're just going to say it's approximately 7%. And J is not within 5%. So we definitely are going to put him right over here with the losers. Not that he is one, but rather it's not the right answer. So go ahead and try it for Sarah, Javier, and Lisa. Now we have the answers listed. Just kind of take a look at the top portion right there. Percent error is defined by that. We already looked at Jay's answer is not the winner. And Lisa's guess and Sarah's guess, Lisa and Javier are the winners. Take a look at the results. Notice the absolute value symbols are still around all of that stuff. Right there and right there. I probably should use the highlighter feature. And but it doesn't really, and we just want to make sure the answers are positive. And the reason why they're the winner is because if you take a look again, these percentages, they're within 5. So the answer has to be 5% or less. So therefore, it is okay. Again, if you're confused, feel free to go back into the lesson by going through digits, or you can just simply ask someone around you, or even the substitute teacher, perhaps. Finally, we have part 3. Actually, I might have made a mistake. Part 2, was there another part to it? Yes, there sure was. Oh, okay. Let's take a look. If you want to try it, go ahead and pause it and don't listen to what I'm going to say, but I'll go through it with my thinking process. Haven't looked at this yet, so you get to hear what my thoughts are. A weatherman predicted 17 inches of snow. The town actually got 1.5 feet of snow. And this year would be the wrong year to predict something less. So we got, this is the prediction, and this is the actual one, so I know it's going to be 1.5. Some people will go ahead and put 1.5, which is fine. But the 17 inches, it would be 17 minus 1.5. That would end up being 15.5. Is that right? Yep. So we got 15.5 divided by 1.5. And that's going to be a pretty bad error. It's going to end up being 10.3 repeating. I just want to remind you that, remember, this is not a percentage. You have to multiply that by 100 still. And that's going to end up being 1,033%. And we're rounding to the nearest percent. Let's take a look at what kind of choices we have. And, let's see, I made a mistake, and I could edit it out to make myself look good, but I also want to point out how math can be learned, and we can understand that sometimes we don't read things carefully. That is 1.5 feet. So 1.5 feet is not quite the same. We have to convert 1.5 times, and if we know how many inches are in a foot rather, it's 12. So 1.5 times 12 is going to get me 18 inches. So I was very much off. So it's going to be basically 1 inch, because that's the difference over 17. And that's going to be that. Which is 5.88, which is not what they have on there as the answer that we're trying to look for. 0.05, yeah. It should be about 5%. So, let's take a look at how this is. I'm not afraid to show you how things cannot be ideal, but the correct answer probably, well, we're very close, but it does bother me that we're not exact. So, you know what? It's because the actual amount is supposed to be the bottom number. So what I did wrong, I didn't even look at it should have been 1 over 18, not 17. Okay? So it should be just not that, but rather 18, because that's the actual amount. Good. Learn from my mistake. You always have the solution part right here. Oh, there you go. 18 as opposed to the 17. I picked the wrong denominator, and that you could tell that made our answer different, because it was 5.88%. It wasn't quite wasn't repeating, but it was off slightly. So technically, you can get an answer pretty darn close, but you want to do it right. Let's go to the second part. Absolute value is just important to understand that we were just looking for the percent error, not negative or positive. Alright, let's take a look at this. Some people aren't very familiar with, if you kind of open up the side and you click on the dot, it opens up kind of what they're talking about.
1 is a value that is 3 units away from the actual value. The measurement 1 is off by 75%.
Okay. You can continue by looking at different things.
2 is a value that is 2 units away from the actual value. The measurement 2 is off by 50%.
And
3 is a value that is 1 unit away from the actual value.
I didn't click on the dot.
The measurement 3 is off by 35%.
Obviously, as it gets closer, you can, in this example, you have a lot of predictions that are under and then over. So it doesn't matter. You'll notice that in a second, that this, along with the 5 right here, is going to be very similar in terms of how the difference is going to be. Let's take a look. Oh, didn't play the audio.
5 is a value that is 1 unit away from the actual value. The measurement 5 is off by 25%.
So what do you know? You got the 3 and then the 5 being very, very similar. And then there was no percent error if you guessed 4. It reminds me of that show, The Price is Right. The price is just where you have a product and you really have to guess how close, get as close as you can in terms of guessing the value of a particular item. We should probably do that in class.
A massive rock. Pretty easy stuff. Well, it's easy as long as you can hold on to the samples. Ow, ow, ow.
Okay, let's take a look at this problem, and then we'll go ahead and let you guys start working the homework. Our run time is about 14 minutes and 19 seconds so far. The dot plot shows the measurement made in science class. The rock's actual mass is 1.1 grams. So, okay, let's take note of that this time. The actual is going to be 1.1. So, I feel like I would call them the same old kids. What goes on the bottom? The actual. I kind of want to locate that. And the greatest percent error among the measurements. Round to the nearest 1/10 of a percent. Are we using the same units? We got grams here and grams here, so there's no conversion. And then they said, what is the greatest percent error amongst measurements? So, we got to look at, is there bigger distance between 1.1 minus 0.8, okay, which is going to end up being 0.3 or 1.1, and that's the minimum, right? And then the maximum right here, minus 1.3, that's 0.2. Well, gee whiz, this one looks like there's a bigger difference, so it should be on the top right here. So we got 0.3, type it on my nifty calculator, that's low in batteries. 0.3 divided by 1.1, and we get a number of 27%. Okay, so this rounds in. Nope, I lied. Round to the nearest tenth of a percent. So if it's 27 repeating, so 272, but it's gonna, that 2 is gonna be rounded up. It's 2727. So that 2 right here is rounded up because of the 7 right there. That should be our answer. Let's go ahead and hold my breath while I check the answers. And yeah, 27.3%. That is pretty much the gist of the lesson. There's another one right here. Go ahead and pause it. I'll show the answer in a second. Otherwise, go ahead and start on your homework. So pause it to take a look at it. Remember, there's the actual mass, which is 5.9. So we have it right here. If you think about it, just by sheer looking at it, if it's equal distant, is that particular one or this one further apart? You can just do the math, subtract it, and see, and put it on top of. Put that difference on top over the actual, and then see if the calculator has the answer, and pause it. But the answers are here. It looks like the one at 7.3 should be more, and that's, oh, it's the same answer we had before. Okay, go ahead and get started on your homework, and if there's any questions, I'll be back tomorrow.